Hi there, this is Theodore. We now got the trained model. Let's deploy it to production, right? Right? Well, actually wrong. So many things can go wrong if every new trained model gets mindlessly pushed to production. Let's start by dealing with the elephant in the room. Don't push a model to production that's a worse performer than the baseline. When comparing to a baseline, you usually compare two things. First, that the new model performs better than the current one, and second, that the new model performs better than in terms of hard-coded metric value like accuracy. The model evaluator component takes some example TF records as input and computes metric values given a model. It can also be given a second model as a baseline for comparison using a resolver node. A resolver node acts similarly to an importer node but auto-detects and returns the latest artifact of some type. If the baseline model is not specified, it's ignored. The evaluation statistics are saved as an artifact and can be visualized with Tensorflow model analysis library. The configuration allows you to specify target metrics and get the change in direction, specify the label key and also a slicing spec. It's as flexible as it gets. The second thing that you should not do is do not push a model that's going to have huge response times or crash to production. This can happen for a variety of reasons. Your inference servers may be configured with lower resource values when you just change the capacity and the architecture of your model. You may want to use CPU instead of GPU, for example, when doing on-device inference. This should not make the model crash or take too much time for one forward pass. The component that deals with this kind of infrastructure deployment test problems is called InfraValidator. There is all sorts of configuration degrees of freedom. The most usual one is just to spin TensorFlow serving Docker instance. There is support for simple Docker containers and Kubernetes. More targets are planned, like AI platform serving. Common validation configurations for this include setting a minimum model load and response time. These for scaling up and user experience reasons. Both the model evaluator and the model validator produce an artifact called a blessing. If all the checks pass, the pushing component looks at those blessing components. If all the checks are successful, move the model to your deployment target. For example, this can be a simple file system directory, some cloud model deployment as a service, or even just a model registry. For simplicity, we're going to deploy the model to a file system. TensorFlow serving can be configured to hot reload models from a specific directory in specific runtime intervals. Before we get started with the code, pause the video and make sure that you have installed Docker in your development computer. Okay, there's not much code to write here, we just need the component wiring and some configuration. The pipeline definition will be complete after these three components. First, add a resolver node for a model channel, then just wire up the evaluator component. Also provide an evaluation configuration with the TensorFlow model analysis library. In this case, we specify slicing based on the trip start hour. There are going to be 24 slices, and the metric to maximize will be accuracy. Of course, higher accuracy is better. A change needs to be greater than 0 compared to the baseline, and greater than some percentage for the blessing to be successful. Then just add the InfraValidator component. The configuration here is minimal due to the sensible defaults. Just declare the Docker config to use TF serving. Note that this is the responsibility of the user to set up the production environment correctly, and it's not the responsibility of TFX. Lastly, configure the pusher component with a file system push destination. Okay, let's run this. If you follow the TensorFlow documentation, the InfraValidator may download the TF serving Docker image locally the first time it runs. Everything should run smoothly and the model should end up at the file system target. Note that under our models from serving directory, there's another subdirectory with a weird number as a name. This is actually a Unix timestamp that's also used as a version number. This interoperates very well with the labeling and versioning capabilities of TF serving. Let's create a new notebook to visualize the model analysis results. I'll call this model analysis visualization. Query the metadata store like all the other tutorials, construct the URI, and render the slicing metric results. It's that simple. Now that's it for the core end-to-end pipeline. Except testing. There are more videos planned to cover more advanced topics like bulk inference, how to run a small TF serving Docker container locally for testing, custom components, the Fluent TFX API library, and how to run the pipeline in different public clouds. Thanks for watching and stay tuned for more videos.